Hey guys, I'm Jay. Today is my LeetCode review vlog on the 30th problem, substring with concatenation of all words. We are given a string S and an array of strings words. All the strings of words are of the same length. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. For example, if words equals A, B, C, D, E, F, then A, B, C, D, E, F, A, B, E, F, C, D, etc. are all concatenated strings. A, C, D, B, E, F, it is not a concatenated string because it is not the concatenation of any permutation of words. We have to return an array of the starting indices of all the concatenated substring in S. We can return the answer in any order. Let's see the example 1 here. We got the input X and words full bar, and output is 0 and 9. And the explanation is the substring starting at 0 is bar full. It is the concatenation of the bar full, which is a permutation of words. And the substring starting at 9 is full bar. It is the concatenation of full bar, which is a permutation of words. And then let's get started with the intuition right now. So my first intuition that comes to my mind is the brute force. Brute force approach. And all I'm gonna do is I'm going to generate all the possible substring with the time complexity of big O of n factorial. And then I'm going to use the KMP algorithm to check if the substring it is a part of the input string, which is check if the string contains the substring with KMP algorithm with big O of m. So as you see, the time complexity of the brute force approach, it is not efficient. So we can come up with another efficient solution called sliding window. And there are 3 key points in this sliding window approach. So the first step is word count and length calculation. First, we are going to calculate the total length of all words when concatenated and the individual word length. And the second step is we're going to use the sliding window over the input string of the size equal to the total length of all concatenated words. And the third step is we're going to matching frequency count. Inside the sliding window, we're going to check if the substring matches the frequency count of the words in the words map we created. And then let's implement this method step by step with detailed annotations. The first step is we're going to take care of all the edge cases. And there are 3 edge cases we have to consider. The first is if S is equal to now, and the second is if the words is equal to now. And the third edge cases is words.length is equal to 0. And for these 3 edge cases, all we're gonna do is to return an empty array list as the problem asks for. But before that, I have to create an array list to be the results to be returned. Let's see, list integer, and it is called a result. And let's create an empty array list. For these three edge cases, we just return the empty array list. And the second step is we're going to create several variables to help us solve the problem. The first, we are going to calculate the word length and the total length of all the words concatenated. Let's say integer word length. Oops, I can simplify the name word length equals words of 0 dot length. As the problem told us before, all the words have the same length. So we just take the first word in the words array and get his length. And then we have to create a window length. The window length it is assigned to the word length times the word's dot length, which is the number of words. And the third step is we're going to check if the total length of concatenated words is greater than the string length. If so, we just return the result. As we can't, as the all of words concatenated can't be the substring of the input string. If as dot length, is less than window length. If so, we just return the result, an empty array list. And the fourth step is we're going to create a word count map, which is for counting the frequency of each word in words, for checking if all the words match the corresponding substring. Further, let's say map, and the type of the key is string, and the type of value is integer, and the name is word count map, and we are going to create a new hash map. And then we'll iterate through the words array and to put all the words with the counts into the word count map. So the code is we're going to have an enhanced for loop, string, word, and words. Oops, I need a space between them. And inside the enhanced for loop, we are just going to word count map dot put with the key is word and value is the count of this word, appearance count. Word count map get or default. This is because if the word is the first time to put in, we have to get the default value, which is 0. Word and 0. And we have to update it with incremented 1. And the next step is we are going to create a sliding window to check each possible window in the string S. And we are going to create another for loop, and we need an iterator pointer, which is called I, starting at 0. And the condition to continue the for loop is I should be less than or equal to s dot length, and minus window length. This is because I stands for the start point of our sliding window, and the range of our I is from 0 to s dot length minus window length. So that's the reason we write our condition here. And we have to increment I after each iteration. And inside the for loop, the first step we are going to do is we are going to create a seen words map here to check how many words we have seen so far. And the code is map string integer, which is very similar to the word count map. And the word could count seen words. And we have to create a new hash map here. And then we have to create a, a counter called J. J is used to count the checked words so far. Let's say in J started at 0, and it is used for count the checked words so far. And if J is equal to the word length, which means the substring matches in the input string. So our next step is we have to iterate the I, which is while J is less than words dot length. We have to check each word one by one. If that word it is a part of the substring. And let's say inside the while loop we are going to get the substring here. And the code is string word. And the code is s.substring. And the range is from I plus j times word length. And the end position is I plus j plus 1 times word length. When we got the substring, and we have to check if the word count map contains the substring. If word count map dot contains key of word. If so, we're going to put the word into the scene words map. Scene words map dot put with words and scene words dot get or default of word and 0. And we have the plus 1 as we have seen it right now. And when we put the word into the scene words map, and then we have to check the number of these words. If a word is seen more times than it appears in the words map. If so, we have to break it because we got a mismatch here. So the code is if seen words dot get words, when it is bigger than word count map dot get word. If so, we just break this iteration. And there is another condition relating to the if statement. If the word count map doesn't contain the key of the word, we can also break the iteration because the word is not a part of the words. And after these two checks, which means the word matches the substring so far, so we have to increment the j to continue the while loop. And out of the while loop, which means all the words matched exactly the times they appeared in words, so we have to add this index into the result. So the code is if j is equal to words dot length, which means all words matched exactly, and we just add the index into the result array. And this is all the code for the for loop. And out of the for loop, we just return the result as the problem asks for. And then let's check for the correctness. And the time complexity for the sliding window is big O of n minus m times k. Oops, we have to correct it. Arrow, not a statement. Word count map put default. We need a time expected. Yes, we have to get Let me check on that. Let me check on this. We get a default here. And then let's submit it again. So the time complexity for the sliding window approach, it is big O of, let me write down it. Time complexity, it is big O of n minus m times k. And oops, we have to need another pair of brackets times k. And n stands for the length of the input string. And m is the number of words. N stands for the number of words. And k stands for the length of each word. This is because in the first for loop, we have to traverse all the possible start points of our sliding window. And the number of all the possible sliding window, it is n minus m times k. N is the length of s, and m stands for the length of words, and k stands for the length of each word. So this is the explanation of this expression. And for another k, it is because inside for loop, we need another while loop to check for k times if we contains the key of word inside a word count map. So this is the final time complexity for this problem. And our space complexity, it is big O of m, as we store word counts and sing words here. And that's it. And this is the end of my LeetCode review vlog on this problem. And you can also visit my GitHub repository here to click this link to open online Gitbook of this project. You can see the detailed description of this problem and solution strategy, problem understanding and intuition, and Java implementation code with very detailed annotations, and the final time and space complexity analysis. And thank you guys for watching. I'll see you next time.